In a little bit, you will learn about RabbitMQ and how to work with it inside your Python code. So, you will learn how to connect to the RabbitMQ server inside your Python code, how to send tasks to it, how to receive tasks from RabbitMQ server, and how to acknowledge that you have completed a task once that has been completed. So, before that, you need to have RabbitMQ installed on your system. And this will be different based on the operating system that you are using. For example, on Windows, you will probably need to have the installer to get the installer from its website and install it. On Linux, you will probably need to set up some repositories and then install it from the command line. However, on Mac OS, which is covered in this video, we will need to install RabbitMQ using the Homebrew package manager. So all you need to do is to open your terminal and enter this command brew install RabbitMQ. And you go ahead and execute this command, and it takes some time to install. Once it has completed installation, which you can see I don't run this command because I already have RabbitMQ installed. And because it is installed, then commands like RabbitMQ server, RabbitMQ queues, RabbitMQ streams, and others are available in my terminal and I can use them. For example, to start RabbitMQ server, I simply run this command and it starts the broker, which opens the server and starts serving the queues and tasks. So let's go ahead and see how you need to work with RabbitMQ in Python. First, we will look at how RabbitMQ works, and then we will use RabbitMQ in our code to enqueue tasks and perform tasks in queues that are managed by RabbitMQ. So let's get started. First, let's take a look at the architecture that we are going to use. Here's the simplest architecture for RabbitMQ queues that are used by applications and code. So we have a queue and we have a producer. The producer produces a task and enqueues it or adds it to the queue. And then tasks wait in the queue until they are consumed or executed by consumer. So the consumer is the other member of our architecture. So this is the architecture that we will use to manage queues and tasks in our Telegram bot application. So let's head over to our code in VS Code. Here I have opened three terminals. One terminal for running the server, which is to control the RabbitMQ server. Another terminal for consumer, where we will run the consumer, and another terminal for running the producer or our bot code. So first, in the bot code, actually, we will receive a request from the user to perform a time-consuming action. For example, to convert a media file or to extract audio from a video. So we will add that task to our RabbitMQ server. So in our bot code, we will send the task to our RabbitMQ queue. And the RabbitMQ server will receive that and hands it over to consumer. So consumer is our other code that is responsible for reading the tasks off the queue and execute them. And then after executing the task, it will send the result back to our user from another bot session. So let's get started. First, I'm gonna run RabbitMQ server. You see that it starts the broker, and now our server is running. So to make sure that our RabbitMQ server is running and even see some statistics from it, we go to the panel that is available in the browser on this port 15672. So you can see that it is running, and here we have the queues and streams section where the list of queues are shown. These are the task queues that have been defined on different times for RabbitMQ. And we also have an exchange. So every task needs to go through an exchange to be executed. So once it arrives into an exchange, it then is dispatched to a queue. And off that queue, the tasks are picked up by the consumer and executed. By the way, in order to log into this panel, all you need to do is enter guest as username and guest as password. All right. Back to our code. The next part is defining our producer. So in our producer, I have added some to-dos so that we can go step by step and define different parts that are required to deliver our tasks to RabbitMQ. First, let's create a connection. So I define a connection and I use the Pika library for that because the Pika library in Python is used to interact with RabbitMQ. I have already imported it, blocking connection. And then we need to pass parameters to it. For that, I use Pika connection parameters. And the connection parameters include host, port, virtual host, and credentials. These are important. I get from appconf. Look, I have defined appconf here, so I can access its members, appconf, like host, RabbitMQ host. For port, I use 5672 because it's always this port unless we change it. And the virtual host, let's also read that from RabbitMQ. vhost. And credentials, for credentials also I use a simple credential, so Pika plain credentials. This class is used to pass different credentials that we need, like username and password. So for username, again, I use appconf.rabbitmq user, and for password, appconf.rabbitmq password. Next, we need the channel. We need a channel in order to connect to our RabbitMQ server. So channel is created by calling connection.channel like this. And then we also define the queue that we want to connect to. So channel.queue declare, we need to pass the name of our queue. So I have already defined it as a constant in tasks as tasks queue in the keys class. And also I pass a parameter called durable. I wanted to create our code, our RabbitMQ connection for the producer, but I defined it in the consumer. The reason is that the way a connection and channel is defined for RabbitMQ is the same for both producer and the consumer. So I defined it here, and now I'm gonna copy it and then go to the bot file, of course my handler, because it is in my handler file that we will create a task and send it to our RabbitMQ server. So let's add it here. I'm gonna paste it here like this. Let's remove this to do. Pika is already imported, so remove this. And connection and channel are also created. Next, in the section that we receive a task from the user asks us to extract audio from the sent video. So here is where we need to create a task and pass it to our RabbitMQ server. So let's actually look at this. I have already created the task. You can see the task has a UID. It is actually the ID of the user that is passed as the task ID. And then we also have the type of the task that I have specified as extract audio. This is also a constant that I have defined. And next are the more important pieces of information like chat ID, user ID, and message ID. In fact, the chat ID is very important. The chat ID is used on the consumer side to access the message from the chat and read the media and download the media in order to extract audio from it. So let's take a look at the tasks definition to see if that is actually correctly defined. Note that uh, I removed the user ID because chat ID is enough. I only use chat ID and message ID. So let's remove user ID because our consumer doesn't require the user ID. The chat ID is the same as user ID, the user with whom we are chatting. The bot is chatting. So let's remove user ID from here as well. So chat ID, and this one will be 2. Chat ID. All right. So I'm gonna change this as well and pass UID as chat ID. All right. Now that we have the task, let's publish the task. We are going to inform our RabbitMQ server about our task. How do we do that? We call channel.basic_publish. And then we specify its parameters like exchange. For exchange, I use the default exchange, which is an empty string. And the routing key which is used to find the task queue to put our task on. So keys dot tasks queue. This is the ID of our task. And then the body is the section where we send our actual data to the queue. So here I use pickle library. The pickle library, in fact, I use the dill library, but I have imported as pickle, which is used as an equivalent to the traditional pickle library of Python. And the reason why I'm using dill is that it is more powerful and more full featured than the pickle library. So I turn the object, which is my task, into a dill object or a pickle object and pass it as the body of my task. And then properties, which uh, allows me to pass additional information and configure my actually connection. Basic properties. Here I specify basic properties like delivery mode, for which I use pika.deliveryMode.persistent. Again, in order to have a persistent connection to the server. We have successfully published our task to the server. Now we are going to go to our consumer file and here receive the task and execute it and return the result as a message to the user. So you can see in the myhandler file here, after we published the task, we told the user your audio extraction task is in queued. You will be notified when it is done. So this is usually the message that you show to the user in order to show them that they need to wait until their task is completed. So back to our consumer file. Let's remove this to do. We have declared our queue. Now, another very important part is defining a callback that will be responsible for handling our received task. So, in fact, the Pika library will call this callback and pass it the task to work on. So let's define a callback. I'm gonna name it CB, and this callback receives several parameters. It expects several parameters like ch, which is channel, and then method, and then props, and then body. And in the body, first we receive the task, we get the task using pickle load s, because we have the object, we have the pickle object, and we want to decode it into a task object again. So I decode body and store the result. And then here we are going to perform our media extraction. So once we have the task, let's actually use our bot client that we have defined. Note that this bot client is different from the other bot client. In fact, they are working on the same bot. However, they use different session files. This is using session bot2, but the other one defined in bot.py is using session bot1. You can see. So back to our consumer. Now that I have the task, let's receive the message. So let's get the message using bot.get messages. Get messages requires chat ID, and we have the chat ID, which is hidden inside task. So task chat ID, and then the message ID, the ID of the message that we want to retrieve. And again, it is inside task. So task dot message ID. You might ask why we didn't download the media file in my handler and then simply send the name of the file, the media file that has been downloaded, to our consumer. The reason is that it might be time consuming to download the file. So instead, I'm using the message ID from the received message, the received media message, and pass it to our consumer. And then our consumer can retrieve information about that message and download its media and do other time consuming operations where it is expected to take time. So here we have the message, and then we can download the media from it. So because we are sure that this is a media message, we can download it. We can pass it the message. So once this call is successful and the download has been completed, it returns us the full path to the downloaded file. So I get the file like this. Then because this file name might contain spaces, let's remove the spaces. So replace, I'm gonna replace any instances of space with something like a dash, and then return the result as file no space. Also, don't forget to strip any trailing or leading spaces from it. And then we are going to remove the extension. So I'm gonna call os.path split ext in order to remove the extension from it. And so our file name will be separated into two parts, the file name and the extension. So it will return file name and the extension. We are not interested in the extension because we are going to change it. And split text, and let's pass it the file no space. And here's the file name we are interested in, the clean file name without the extension. And the extension that we will add for this is mp3 because we are going to return an mp3 to the user. So out file name will be file name plus mp3. All right, now we are ready to perform the actual extraction using FFmpeg. And by the way, I have FFmpeg installed on my development machine. So on your server, this needs to be installed. And then you need to use the FFmpeg library for Python as well to interact with the actual FFmpeg binary. So let's call ffmpeg.input. We will need to pass the input file name for this. So file no space will be the input, and the output will be our out file name. And then because the file name might be existent currently on the system, we need to call overwrite output to overwrite it if it already exists. And then we call run to run the task. This, of course, will return the status of execution. So This will be an array, so let's read it. If status 1, this is where the error is stored. So if there is something stored here, we say an error has occurred. So bot send message, we send a message to the user, chat ID, chat ID, chat ID is the one we received from the task object, so chat ID, and the message is failed to convert or failed to extract media file. So this is our text. And also because a lot of the operations that we performed here might face some errors, we put them inside a try catch block. So try, and I add an except clause here, except exception as E, and we simply say here bot.send message chat ID is equal to task chat ID, and the text is failed to perform media or audio extraction. Otherwise, if the status is not present, means that it has been successfully performed, the task has been executed. So we can say else but send message. Actually, we will send the audio that has been created. So chat ID is the same task chat ID, and the audio file is the name of the output file that we have obtained, like this. Before we go forward, I have to also, after removing the spaces from the file, actually rename the file to this new file name. So shutil is used for that, and we call move on it, move the old file name, which is file, and the new file name, which is file no space. And now we can keep working on our code, on our file name without any space. So now that we have our callback, we can go ahead and start consuming the task. So for that, let's remove this to do as well. I use channel.startConsuming. This will tell Pika to start consuming and receiving tasks from the RabbitMQ server. But we are not done yet. Here we assume that the task that we receive is actually the media extraction, the audio extraction task. But what if we have another type of task? So for this, and in order to make our code work for other scenarios as well, it's good to have a match statement for task type, and depending on the task type, decide what operation to do. So I'm gonna move it and indent these lines, and then here case, here I say if the task type is task type extract audio, Then we do these operations. If it is not, if for example it is something else, we simply pass. We don't do anything for now. If in future you add another type of task, you will add it here. Also, before starting to consume, there are some tips and some important things to consider. For example, because we have a simple queue, we don't want to have a lot of tasks accumulate on top of each other and wait for execution. Actually, we want to have one waiting task at a time. And this is determined using this basic QoS. And it has a parameter called prefetch count, for which I pass 1, so that a maximum of one task will be idle in our queue at a time. So basic QoS, and then channel basic consume. Again, that is used to tell RabbitMQ that we are going to use this callback. So we have defined the callback, but we haven't told anything about it to the Pika library. So basic consume and on message callback. When a message is arrived, pass it to this callback, the name of the callback that we defined. Also, don't forget to specify the queue name, which is important. So queue equals keys.task queue. So we are ready to run our code and see if it works. First, we run the consumer. So you can see I have started the consumer. It is running. And then I'm gonna run the bot, python bot.py. Okay, that started. I open the bot and I use this key to extract audio. It asks me to send a video file. So I'm gonna use this video file that I already have in my chat. So I forward it to this chat. You can see the message, your audio extraction is enqueued. Let's take a look at consumer. The consumer should be working on the task now. Okay, looks like it is conducting the operation. There we go. It worked. It performed the extraction using FFmpeg and sent us the resulting audio file. Before I wrap up this video, I just forgot something very important. And although our code worked and it performed the action that we wanted and it executed the task, however, we forgot to acknowledge the task. So after a task is complete, we need to tell RabbitMQ that this task has been completed. Otherwise, it will keep waiting and no other task will be accepted. So in our callback, after everything is done without problems, we say channel dot basic act, meaning that we want to perform a basic acknowledgement that our task has been completed. So we pass a delivery tag, and that delivery tag is received from the method that was passed to the callback, this one. So we use the delivery tag that we receive from its method in order to inform the server that this task has been completed and it can move on to the next task in the queue or accept new incoming tasks. So in this video, you learned how to launch a RabbitMQ server on localhost, how to connect from your Python code, which is indeed your Telegram Pyrogram application, to that RabbitMQ server and define a task, send a task to the queue, and then you learned how to create a consumer code that consumes tasks from your RabbitMQ queue and executes those tasks and then returns the result to the same bot chat, of course, using another session file and another client instance. If you want to learn more about Telegram bot development using Python, take my full stack bot development course on Udemy using the link in the description.